So let's continue our journey on how to do derivatives not having to use the difference quotient. So we learned a rule for powers. We learned that when you do the derivative of e to the x, its derivative is just e to the x. We learned that if you have ln x, its derivative is 1 over x. We learned that if you have cosine, its derivative is negative sine. And if you have sine, its derivative is negative cosine. And keep in mind that when we're finding the derivative, we are trying to find the slope of the tangent line. We're trying to find a rate of change. Later in applications, it'll be finding the velocities. And so now what we're looking at is what do we do if we have a product, meaning one function times the other? And what do we do if we have a quotient? So the product rule and the quotient rules just give us some shortcuts on how to do those two situations. And what I would do if I was working on this worksheet is I would look and say, okay, this one is 2x times cosine, so that's going to use the product rule. This one's a fraction, so that will use the quotient rule. This one is x cubed times e to the x, so that's product. A lot of times I'll do a big dot or parentheses to help me separate out the two parts in a product rule. So like here, this is negative 2 sine x times cosine x, product rule. This one's a fraction, quotient rule. Here that already has the dot, I'm going to just make that bigger, product rule. This is division, quotient rule. And this is one polynomial times the other, so product rule. Okay, so then once I know which rule to use, I just go ahead and use it. So this is saying if you have one thing times the other, so function f in this case would be the 2x, and function g in this case would be the second function, or cosine x. And what you're supposed to do is do plain f, meaning the original f. So when I go to do my derivative, I'll take the original f, which is 2x. Then I'm supposed to multiply it by the derivative, that's why the prime is there, of the second part. So now I have to do the derivative of this. And the derivative of cosine, which we learned before on day 1, is going to be negative sine x. Then there's a plus sign. Then I'm supposed to use g as is without the prime, so that would be the cosine x. And then I'm supposed to multiply that by the derivative of the first part. So the derivative of 2x, and if you think about 2x to the 1 power, you can use the power rule. The 1 comes down in front to multiply by the 2, and then the x, you have to take away 1 power, so now it's to the nothing power, and it's gone. And then all you do is clean up, simplify, multiply, whatever you can do. So here, a negative in here is weird. So you'd write it out in front, negative 2x sine x. And then the 2 is a coefficient, so it would go in the front as well, plus 2 cosine x. And that, my friends, is your derivative. So you're just going through and writing the first thing times the derivative of the second part, plus the second part times the derivative of the first part. So don't make that harder than it is. I'll do one more for you. So here my two pieces are x to the third is like my f, and e to the x is like my g. So I need to do first thing times derivative of the second plus second thing times the derivative of the first. So my first thing, when I go to do g prime, my first function is just x to the third. Then I multiply that by the derivative of e to the x. But the derivative of e to the x is just e to the x. So that stays the same. Then I add the second part, so that's e to the x, times the derivative of the first part. So think about x to the third. There's a 1 in front. I need to multiply that power by the number in front, so that's a 3. And then take away 1. I'm using the power rule from yesterday. So 3 minus 1 drops the x power to a 2. So I would have g prime x equals x to the third e to the x plus, and then you usually put the x part in front, so 3x squared e to the x. And that is going to be my derivative. So if I had to find the slope of a tangent line or instantaneous rate of change or instantaneous velocity at a certain x value, I would just plug it into this function. So in 4, in 6, in 8, you're going to continue to use that same product rule. So watch for the multiplication, identify what's your first function, what's your second function, and then just follow the pattern. The quotient rule looks really complicated, but this one's just saying, hey, I'm going to take the top and divide by the bottom in order to find the derivative. That's all this notation means. I'm going to follow this rule. In the bottom, I'm not doing any calculus. I'm just going to square whatever was on the bottom. Then on the top, it's similar to the product rule. I'm going to take the bottom as is, because there's no prime, multiply it by the derivative of the top, but now I'm going to subtract, so that's different than the product rule. And then I'm going to have the plain top, no derivative, times the derivative of the bottom. So I'm just following a pattern. So it's not complicated, it's just new. So in this one, number 2, this is a quotient. This is going to be the thing they're calling U up here, and this is going to be the thing they're calling V, the top and the bottom. So according to my formula, I'm supposed to take the bottom squared, 2x minus 3 squared. Now, normally I don't multiply that out. I just leave it just like that. So you don't have to FOIL the bottom out. The simplifying that you're going to do is all going to be on the top. Okay, then I do the bottom again, no prime. So I'm just going to take the 2x minus 3 to do this part. I'm going to multiply that by the derivative of the top. So I have to think about this when using the product rule. I know that the derivative of a number is nothing, so that's going to disappear. And the derivative of my 3x, keeping in mind that that's currently to the 1 power, the 1 would drop down, multiply by the 3, and the x would lose the only power it had, so it would disappear. So this is my u times v prime. I'm just following along. Now I need to subtract, and I always do a big bracket because I have to subtract this whole thing, and I don't want to forget to distribute the negative if that's necessary later. So then I'm supposed to put the top as is. So the top is my 3x minus 2, and then I'm multiplying it by the derivative of the bottom. So I look at the bottom, same thing, it's a power rule. This is to the first power, drops down, multiplies by the 2. X loses the only power that it had, so that's gone. And then the 3 is a constant, so its derivative is 0, so that disappears. So now all I have to really work on is I need to simplify the top. And that can be FOILing, that can be distributing, that can be combining like terms. In this particular case, I don't have to FOIL, I have to distribute my 3. So I'll have 6x minus 9. And then in here, when I distribute the 2, I'll have 6x minus 4. It's all still over 2x minus 3 squared. But this negative, like I said earlier, distributes to everything. So the top becomes 6x minus 9 and then minus 6x plus 4. But when you go to simplify that, you can see that these cancel. So negative 9 plus 4, in the end, my derivative for number 2 is going to be a negative 5 over 2x minus 3 squared. And again, right now we're just practicing the skill of finding the derivative. Later on in calculus, you'll actually use it for applications and finding stuff, but we're just practicing these rules so that when you take calculus next year, either at South or in college, this won't be brand new. Okay, so there's only 3 quotient ones. So between the ones in the example and this one, hopefully you can kind of follow that rule and finish these out. If you're still having trouble, maybe rewatch the notes videos or go back and watch this video again. Sometimes if you're trying to write and listen at the same time, it gets tricky. Hopefully that helps you out. And then there's going to be a second day of practice, so I'll make a video of doing some problems off of that one as well. So hopefully you can start to see the patterns. Have a great day, you guys. Bye.